demo showcasing some portion of the 031 release. So I wanted to talk about just briefly before we get started the some of the features that you can expect in 031. So it is a point release. We have so the main there's not a ton of major seismic shifts there, but I wanted to highlight a couple of things. So one thing that you'll see today is the flat file loader got a lot smarter, and loading enrichment types got a lot. Oh, we should probably record this. Oh, we are recording it. All right. So the flat file loader got a lot smarter and got a lot more integrated, which you'll see a demo later. One of the other big things I would say that changed is the work by Justin Leet in getting our reliance on MySQL removed. So that was a big thing from a community perspective. We were depending on an LGPL library. We've moved that instead to, I think, a better solution for geo-enrichment. I don't think that's going to be demoed today, but that's good, and we'll document it. I also want to point out that the absolutely great work by Matt Foley on creating, essentially on collecting our various READMEs into a site book that's just really nice and is able to be hosted, so we can snapshot the documentation on a per release basis. That's huge, I think. So thanks a lot. If you are on the dev list, which I urge you to be, please take a look at the release candidates that are being put out. I'm placing the site book with the release candidates, so you can see that. You'll see that today. And with that, I think we can get started, unless anyone has anything else that they think needs to be pointed out about the 031 release that I missed. Okay. So Mike McClavick and I are going to be joint demoing the work on the flat file loader and some of the enhancements done to that to extractor loading. Mike, are you there? Can I pass the ball to you?
Yeah, I'm here. Can you hear me?
Yep, I can hear you.
Great.
Can you take presenter?
Let's see. Hold on a second here. How do I grab presenter from James?
Let me just do it.
I think I can actually just...
Here. Why don't you work inside the screen session?
Oh, I was say I could share as well. Okay. 1 second.
So I'll start out, and then so there's two parts to this demo. One is the modifications done to the flat file loader. So before, we had two separate applications to run. If we wanted to import data into either threat intel tables or importing data into enrichments for HBase enrichment. So you'll notice there are a lot of executables there. We used to have a bulk load, a threat intel bulk loader that was improperly named and was completely separate from the flat file loader. So instead, when the flat file loader worked not using MapReduce, the bulk loader worked using MapReduce. So instead, we merged the capabilities and multi-threaded the non-MapReduce based implementation. So Mike's going to show that out as a result of some of the other work that he did. But just quickly, just so you can see the command line. So just like there was before, if you want to do a MapReduce based, or rather, if you want to do a regular flat file load that's multi-threaded, you can indicate the parallelism with a -p flag. If you want to do this via MapReduce, you can indicate a mode MapReduce, right? A dash M MR. The other thing that was modified was before you could only handle files that were for the flat file loader. You could only deal with files that were local. We modified that so that, or I modified that so that you could use you could pass URLs and it'll go out and get it. You can handle gzip files and you can handle zip files. And obviously for the MapReduce portion, it assumes it's on HDFS. You can also go and grab HDFS data and pull that in locally. So lots of different ways to import data and bring the data to the executable as opposed to having to spend a lot of extra time staging it. And with that, I'm going to move on to Mike to talk about his modifications to the extractor config.
So previously, the extractor was limited in capabilities. You were able to specify a list of columns that you wanted to extract given a specific type of extractor to publish into HBase. And so what we ended up doing is extending those capabilities by adding stellar transformations in a couple of places in a couple of different ways. So I think maybe the first thing I'll do is pull up the configuration file. It's maybe a little bit hard to read given the red. Let me see if I can. You see that okay?
It should be shared now, right? Can you see it on the shared screen?
Oh, that's right. We're using your screen. Hold on a second.
It's there.
Okay. So we added a couple things here. So when we create a record in HBase, you have a couple things. You have the row key, and then you have the additional values or the metadata that get stored with the column families in HBase as well. And so what we added here was the ability to not only transform but filter in two ways. So the first thing and the most obvious would be that you have the data coming in that you're extracting out of those columns, and you want to be able to filter on, or excuse me, transform that particular type of data. So what we did here, if you see the property for value transform, we allow you, similar to what we have exposed through our parsers and other threat intel and enrichments, we've exposed the ability to provide stellar statements, stellar expressions to transform that data. So in this particular example, what we've done is use the domain, top-level domain remove tool, remove function, in order to extract basically just the root domain out of the top domains list that we're passing in. So what we did for this particular data set, we pulled down the Alexa top 1 million enrichments. We pared that down just for the sake of the demo to the top 10,000. And so what it'll do is, for instance, take google.com and it'll return Google. And so instead of publishing the full value, now you've got a lookup that you can, basically you can look up based on Google as the key. In addition to that, what we've also done is provided a filter that's independent of those transformations. And what this enables you to do is specify basically a predicate for the values that returned out of that transform. So for instance, if the domain ends up, once you remove the TLD, ends up being 0 length, you're probably not going to want to store that. So this allows us to filter out those results as well. And some data sets actually include the top-level domains, for instance, com, net, org, things like that, and that's not really all that useful to us for what we want to do for loading top-level domains, so we want to filter those out. In addition, there is a filter and transform for the indicator column, and the indicator, so just to back up a moment about how we store our enrichments, the row key is comprised of an indicator and a type. So the type, you can see in the properties file here, is listed as top domain. So that's part of the key. In addition, there's an indicator. And so what we provide is the ability to specify what type of indicator that you want. And here we're going to use the domain as the indicator. So basically, when you look up and want to see if you hit for a particular domain, if it's in the top domains list, it's going to be a combination of top domains and that actual domain. So going back to the previous example would be Google would be your lookup. And so then you would know that you have a hit. Again, similar to what we have for the value transformations and filters, we've done the same thing with the indicators. So based on that indicator column, you can not only do transformations independent of the value transformations, but you can also do filtering independent of the value filters as well. And you can see that there, once again, we're doing removing the top level domain from the indicator column and also verifying that the length is greater than 0. So I think at this point we could probably go pop. Oh, one more thing actually I want to mention here. One additional feature that we've added to this that again exposes functionality similar to what we've exposed in the parsers and enrichments. There's a zookeeper quorum property as well. And what that allows us to do is if you have any properties that are specified in your global config, it will be able to hit zookeeper and extract those or pull those values out as part of your transformations and filters as well. So that is all exposed again through the stellar transformations and predicates that we have exposed here. So we can probably pop over to the demo part of it now.
Do you want to? Yeah, okay, you're driving. Good.
Is this the local one? Yeah. Okay, so all I'm going to do is run 2 jobs. So again, we've got a data set that we've pared down, again, because this takes a little bit of time to run, but we've got, we pared down the list of top domains to a list of 10,000, and this file has a rank. It's a comma delimited file with a rank and a list of domains, including the top level domains. So again, like google.com, yahoo.com, so on and so forth. And so what we're going to do is load this file using a parallelism of 5. And this is loading from a local file. So it's just going to take a moment to spin up.
It takes a while to get started. So just I'm not. I think this node might be a little bit overwhelmed. There it goes.
So as it does the import,
it's a lot more verbose. You'll notice as well in the descriptions.
Yeah, so we've got when in adding the stellar transforms, we've basically enabled a lot of additional functionality for connecting to HBase and Zookeeper, and so that's kind of where a lot of this additional logging output is coming from.
Right.
Which should be noted that you can change that logging output. One of the options that I forget if that's new or if that's been there all along, but you can specify a log4j-properties file to filter out things if you want to change that.
That's been there actually, but now that we've unified all the different ways to do imports, it's available for MapReduce as well as for the local one. So for local, you'll notice that it's running in parallel, and it's running relatively fast for this node. And it should stop when it hits around 9,000. When it hits around 10,000. Running with a parallelism of 5 might have been too hopeful for this particular.
Okay. So we've got, so what I'm going to do is quick count on the table just to verify. We expect that there's around 10,000 records.
But not exactly 10,000, because some of them should have been sent to the same key, because we're removing top-level domains. So google.co.uk and google.com should be 1 record, not 2.
Yeah, and I found especially for the higher level or like the top 50, top 100, there's a much higher percentage there because again, as you mentioned, you're going to have a lot more of same domain with different top-level domain. So, okay, so we got 9,289 records.
So we're going to clear the table and then run the map. Then run this again using MapReduce instead of local. And you'll notice the keys structure looks just like you would expect the key structure. A hash followed by the enrichment type, followed by just the domain without the top level domains. All right, so we've truncated the table and it's going to rerun with MapReduce. This does take a little bit of time because the file's small enough that it ends up in 1 input split, so it's all being done and on one node over the network. So and you'll also notice we stage the data in /temp on HDFS for that. And if you were to go to the MapReduce console, you would see a job titled /temp/top10k.csv to the HBase table and column family. So you can track the status of the job, which will also be tracked here. And this takes some time. You also notice that this is, so each of the tasks get the connection to Zookeeper. So any Stellar functions which require a global config can be run on the MapReduce, on the mapper tasks. And this is a map only job. I should also be noted that the configs are backwards compatible for the extractor from older versions of 0.3. So for 0.30 and before, the old configs still work. You don't have to do stellar transformations or anything like that. It's just if you configure the transformations, then they'll be available.
Same thing goes for the Zookeeper quorum as well. And you can actually do the transformations without the Zookeeper quorum. You just won't have access to certain features from like the global config. But it should still work.
And with that, is there any questions from the audience about any of this?
I mean, what's the overall guidance between using the locally parallelized version versus the MapReduce version? I guess, is it just kind of raw size? If the files are huge, then go MapReduce?
Yeah, I think it's size. It's also ease of staging. So one thing that I noticed here, we were trying to do some of the Alexa enrichments that a lot of people are going to have URLs, right? They'll just pull this directly from the network in. We want to be able to support that, and you'll notice it's the same count there. We want to be able to support, that kind of use case. But yeah, if you have a 1,000-line file that you want to import, it's kind of silly having to push that onto HDFS and start up a MapReduce job versus just being able to specify, hey, you can just pull this down locally, and in terms of the limiting factor before for that was the latency in the HBase puts got really painful, right? You do see a linear scale up whenever you go parallel into HBase. So for small files, it just makes sense to not have to put the stuff on HDFS and kick off a MapReduce job.
Got it.
Anything else? This is a good question.
Should probably also note with the import from local, I think default parallelism, is that set to 5?
No, default parallelism is set to the number of cores that you have.
Right.
Okay, so I think that's it, unless there's any other questions. With this, who wants to go next?
Hey, Casey, wait a sec. So one of the things I think we have to do is set the stage as to why we did this and why we have this feature. So this kind of enrichment is very helpful in security analytics use cases for a couple of reasons. Number one, when you model the data, chances of anything malicious coming from, top Alexa profiles or top Alexa domains is significantly less than, the domains that are not in that list. So number one, if you have capacity problems, it gives you a capability to filter some of the feeds. So for example, if you wanted to filter filter out YouTube, Facebook, Twitter, things like that. You'll have a capability to do this with this type of enrichment. Also, if you wanted to model from a historical perspective, proportions of traffic, going to these domains as opposed to domains that are not on this list, it's another, potentially useful metric. As well, if you wanted to data mine or profile distributions, within these URLs versus the URLs that are not on this list, it's also a good type of enrichment to have. You can, derive statistics, things like entropy and just general historical distributions of flows that go into each one of these domains, and then model them against the domains that are not on this list to see if there's any type of deviation between what's on the list as opposed to what's not on the list. So it has a pretty profound and significant impact on the way you do analytics. So it's a very useful enrichment to have.
Yeah, absolutely. That's a good point. That's a very good point.
All right, go ahead, guys, with the rest of it.
Okay, who wants to go next? Matt Foley mentioned he wants to go over the doc book. I saw that on the dev lists. If Matt, if you're talking, you're on mute. Still can't hear you. Oh, okay. Matt's trying. Okay. Well,
hey, if we figured out how to give control, I can do the 2-minute MySQL replacement overview.
Oh, that'd be great. Yeah, absolutely.
Since I do need to show a web page, it's probably easier if I am sharing.
Yeah, let's see. I don't know how I got control.
So I just made you a host, and I think once I make you a host.
Okay. Justin leads the host now.
Yeah.
All right. Stop. So let me know when somebody can see it anyway.
Yep.
All right. So just for a little bit of background, you guys may know this. We do some geo enrichment in our just kind of as the normal course of things, grabbing things like we can see here, city, country, lat, long, postal code, and so on. Carry that all the way through. That was dependent on MySQL. We wanted to get rid of that for the reasons Casey stated before. And the solution we ended up replacing it with is the same data source we were using originally. MaxMind's GeoLite database actually has a more complete / newer version of their data that includes some more fields. There's a separate ticket for if we want to include more of those or not. And it also has a kind of conveniently packaged up database form that we can use. So I don't know if people are asking questions or if that's Matt.
No, just keep going.
Still Matt. Yep. Okay. So we wanted to use that just because it's packaged up by them. We were doing some parsing and other things that we didn't want to handle before. So we ended up doing that. Things live in HDFS. We'll get to that in a minute. But long story short, for the vast majority of everything we have, it's entirely on the back end. Like you can see from here, everything lines up the same way. If we grab a particular IP, which is this, and we go over here to their little demo page, everything lines up. It is Strasbourg, France, and still Strasbourg, France. So the main difference is things live in HDFS. When we want to make queries, for the first time, we just grab this file. The file is defined in the global config. So I've already spun up the Stellar shell. And we can see that part of our global config is the GeoHDFS file. So that will not be pulled every single time that you go to query anything. It will be pulled until that file changes, and then pulled again, and we'll be using it just as an ongoing basis. So we added some Stellar functions to this, specifically GeoGet. So I can pass, I think I pasted that along. The first time we'll pull down the file from HDFS, so we'll see a bit of a delay, and then afterwards it'll be pretty much instant. So we let that go for a second or two. France, Strasbourg, postal code, and again, running again, everything looks fine, and we can start querying whatever else we want. So this is, for instance, Google's DNS server, one of the ones that they provide, shows up in Mountain View. And additionally, if you don't want all these fields, for instance, say you only want the country, you can pass a list of the fields that come back, and you will only get, for instance, US as a string, or if we also want country and city, we get it back as a map. Country is US, city is Mountain View. The main kind of pain point with this right now that we see in a lot of other areas is just handling configuration management from a single place. There's a script right now that will update and push that config to Zookeeper, but since there's kind of a few places where that touches, like there's the files stored locally that, you know, like in general with Stellar doesn't get updated when you update things, you know, you just have to be a little aware of that. But generally before we were just, you know, pulling down one copy of the geo file and not updating it anyway. So it pretty much matches what you already have. And on a clean install, it should install everything set up to go. Just grab the file in the first place and you should be good. Any questions from the short version of that?
So not necessarily a question, but a comment. The reason why I like the new architecture of instead of relying on MySQL is sort of out of the box. While you can shard MySQL and replicate MySQL, etc., sort of out of the box, we get as much parallelism as Storm gives us because we're pulling these things locally. And before there was some issues around without the Stellar function, it wasn't entirely doing GeoIP stuff wasn't integrated into the default scripting interface for Metron. So now it is, which is great. We also had a problem before with if you wanted to update the GeoIP information, you'd have to construct like a separate table and then reconfigure and restart topologies and things like that. Whereas now you just upload, you know, modify Zookeeper and it pulls it down in the background and it's then it's atomic. There's no downtime, which is great. So good job. I think it's an important feature just beyond relying on an LGPL component. Now this is a lot better, I think.
Yeah, thanks for fleshing that out, Casey. Like I said, this was kind of the short version, and I glossed right over that, so I'm glad you brought it up.
No problem.
Anything else? Or Matt, are you all set?
Yeah, can you hear me now?
We can.
Excellent. If you can pass me the presenter dongle.
Let's see. If I'm the host, I might have to be the one to do that.
I think James has to. I wasn't able to before.
I'm not able to anymore because I'm not the host anymore.
Yep, I just passed it to Matt.
There we go.
Okay.
I'm the host now. So, can everybody see my screen?
Not yet.
Not yet.
Not yet.
You're also breaking
Okay.
up.
Hang on. No, I've got to share my screen now actively. Okay. There we go. Is it working now?
Yep.
Yep.
Good. Okay. So, in the past, we've documented stuff in the wiki and in README files in the source code. And we took a poll, and the developers have a really big preference for documenting stuff in README files because it's close to the code. So if you're doing something in analytics and statistics, it's just natural to document it down by the code you're changing. And likewise, if you add a feature, you can just add another file with the information about that. But README files aren't very good for end users because they don't want to have to browse through source code to figure out how to use their features. The wiki doesn't have that problem, but it tends to get out of date because it is far away from the changes being made in the source code. So it's better for long-lasting stuff that that doesn't go obsolete as quickly. But for the detailed information about how to use the Metron features, what we decided to do was collect all the MD files, both the README files and any other MD files that the developers write, collect them and generate a standard hierarchical navigation tree. And that's all done automatically. And as you can see, it has details about just about everything. You've got formatting exactly the same as you'd expect from the README files. Under Platform Common is actually the main Stellar language manual, and so it's got the big list of Stellar functionalities, and you can click through to get to the details about any of it. Basically, we just wanted to show this to everybody so that the user teams would be aware that this exists now, that we basically have a book pulled together with all the details about our various features, and also for the developers, so that everyone is aware the README files are going to be pulled in like this. And also, you don't, it's not just the readme.md files. You can also create other MD files. For instance, when Mike did the hyperloglog plus, he created an HLLP.md file under the statistics directory, the Metron statistics directory. And as you can see, the algorithms pulled it in also, and it generates sensible names for everything. That's about all I had. Oh, one more thing I should say about it is if we, basically right now, this sitebook is under the release directory, but we're going to make a room for it under the Metron homepage, so that when you click on documentation, you'll actually get the book. So that's about all I had. Any questions?
I just had one comment I wanted to say. First off, is great, but second off, I was in a situation last night where I was documenting a pull request, and I wanted to color code things. And GitHub's readme.md or GitHub's Markdown editor doesn't accept span tags or font tags in HTML, whereas this does. So this is actually, I think, better than the readme.mds that you see, browsing GitHub. So just so you're aware, this is very nice, I think.
Thanks for pointing that out. Yeah, the tool we use to build the HTML site is called Doxia. It's a popular Maven plugin, And the dialect of Markdown that it speaks is a little different from the dialect that GitHub speaks. And so I wrote a translator that rewrites certain Markdown elements automatically so that it works with Doxia. All right, guess that's about it for that then.
Does anyone have
Thank
anything
you.
else they want to show?
Just a quick question on the documentation. So first of all, great to see. I'm far more towards the user consumer side than I am the developer side. So something like that is great for me, and I can see it being really useful for people that are looking to consume the platform. What we've got is a gap between the actual documentation that appears in the README, and then you've got things like the reference application sort of side of things that's kind of putting what we have in the READMEs into practice. Do we see some of that material kind of migrating into the READMEs and therefore staying current and up to date, or do we see that that evolving down a different path?
Yeah, that's a good question, and we've really got complete freedom in what we do. Obviously, there should at least be cross-references between the kind of the live documentation in the site book and the more static documentation in the wiki. As you point out, the large stuff, the kind of heavy-duty examples and so on, probably will continue to live in the wiki, but we do have freedom as we get feedback from users. We certainly want to continue making it more usable and more useful, but also more up to date and reliable. So yeah, your input is encouraged on how you'd like us to address those problems.
So I know I've started to do worked examples as part of the READMEs. I did whenever I did the outlier analysis stuff. And the reason why is because I want it to be kept up to date, essentially, and I want it to be versioned with the version of Metron, because config files change. But even right now, the documentation and the blog posts have to be kept up to date, but we're not versioning it. So if someone's installing 0.30 and we update it for the new config for 0.31, all of a sudden, if they're trying to follow it in a 0.30 install, it doesn't work, right? So I would like to see most of the worked examples moved into this structure, but that's just
I think that would be great. I think the documentation, the README style documentation in this format, having more worked examples would be really, really useful.
Yeah, actually, Matt, would you mind going to the statistics package over on the left there? Just want to show one example of something that's in there. So could you scroll down here? Could you just scroll down? So under the stellar functions, it's just sort of hidden away, right? I think it needs to kind of be in people's eyes. Keep scrolling. And see, you notice that here an example. There's literally a worked example of how to deal with the outlier analysis stuff, right?
Nice.
I think I'd like to pull that out and to kind of collect a lot of the worked examples in like a separate module that works for all of Metron, maybe like a docs module or an examples module or something like that. At least that's my 2 cents about it.
No, that's really good. That's really good. Especially for someone that's coming to this new and fresh, having a worked example they can work through actually makes it real for them, helps them to understand it significantly. I mean, a lot of you guys have been kind of heavily engaged and know your areas inside and out. People that are trying to consume this for the first time end to end, it can be bewildering.
Right. I've noticed one sort of difference in the worked examples that I construct versus the worked examples that are the worked examples that we construct are very sort of feature specific. as opposed to holistic. Like the blog posts are more holistic examples. I have something I want to accomplish. I'm doing an end-to-end thing where, you know, I'm motivating this in this way. Like even here in the outlier analysis stuff, it's synthetic data. It's showing a particular, you know, algorithm, not necessarily a particular feature. So we'll probably have to rethink the scope in which we think about the examples. And I think there's room for both. But honestly, I think both of them fit within this construct that Matt's created.
Yeah, I mean, I think the value of that end to end is getting people up and running from like what we call the reference application today is getting people up and running. The value of the individual kind of examples you've got embedded or started to embed within the individual sections are, okay, maybe I've run through the end to end and now I've got this all running, but now I want to understand what I've actually done. And that's when you'd go to like the individual feature specific examples maybe.
Yeah, I agree.
Yeah, and yeah, yeah, we have some good examples, but lots and lots of places we could use additional.
Okay, anything else that anyone wants to show? So I'll be creating an RC4 at around 3 o'clock in around 2 hours, 2.5 hours or so. And hopefully this will be the last RC. Fingers crossed. So hopefully we'll get 031 out in a nice clean way over the next week.
And the summary of this recording and a link will be sent out by close of business today. It'll be posted on YouTube. All right, thanks for coming, guys.
Great stuff.
Great, thanks everybody.